Welcome to quantitative aptitude video on probability from careerright.com. Being one of the favorite topics of examiners, every placement test, job interview, bank, MBA and other exams have at least 2 to 3 sums on probability. Today we learn probability in an easy way and see how to quickly solve sums related to it. You can practice probability on careerright.com, which has practice test as well as 1000 plus aptitude questions. So let's begin with probability. Probability means nothing but chance. Generally say whenever we go out or whenever we are talking with our friends, we place a bet like, okay, there is a 50% chance that it is going to rain, there is a say 80% chance that it is going to rain. This is nothing but chance. This is nothing but probability. But probability is not expressed in terms of percentage, it is expressed in terms of a fraction. Okay, something ABC upon XYZ. Okay, this is nothing but probability. Now let us see what exactly is formula of probability. Instead of looking at some weird formula, we'll take a look at formula of probability in a very easy language, right? So what exactly is probability? Probability is nothing but what I want, okay, what I want divided by total. This is very easy, very easy format of what we call it as probability. If you remember this, probability nothing but what I want divided by total, you will be able to solve all the sums related to probability. Let us take an example. What do we mean by what I want and total, right? Let us say this is a box and it has some balls. Okay, it has some balls. It has say 4 red balls and say 2 green balls, right? Now I want to pick up a red ball. So what do I want? I want 1 red ball. How many red balls are there? 4. I want red. Okay, so 4 red balls are there. So whenever I try to pick 1 red ball, it can be any one of the 4. Okay, so what I want is red. So how many red balls are there? 4. Now divided by total. Total means how many total balls are there? 4 plus 2 green, that is 6 balls are there total. So probability of picking up a red ball is 4 by 6. See how easy it is. Just remember, probability is what I want divided by total. Okay. Now apart from this, there is another very small concept, and what it is, whenever we have the word and, we will multiply. Okay, whenever we have the word or, we will add, right? And is multiply, or is add. If they say this and this, that means we multiply them. If they say this or this, we add. So just remember, and or, multiply and addition, right? Now what we know, probability is what I want upon total, right? What is total probability? Total probability will always be equal to 1. Why it is always equal to 1? Let us see. Okay, take this example only. What have we written? We have written that if you want to select a red ball, okay, there are only 2 types of balls, red or green. So whenever we pick a ball, it can either be red or it can be green, correct? What is the probability of selecting a red ball? We have found out 4 by 6. Now what is the probability of selecting a green ball? How many green balls are there? 2. How many total balls are there? 6. So there are only 2 types of balls. So either we can pick up the red ball or we can pick up the green ball. So what is the total probability? Probability of picking the red ball plus probability of picking the green ball, that would be 4 by 6 plus 2 by 6, that would be 6 by 6, that is 1. So total probability is 1, right? So this can also be written as probability of an event happening, okay, plus probability of the event not happening would be equal to 1, right? This is the total probability. Probability of selecting a red ball, okay, and probability of not selecting the red ball. There are only 2 types, red and green. Selecting the green ball means you are not selecting the red ball. So probability of selecting the red ball plus the probability of not selecting the red ball is 1. Just remember, total probability is all, look at the left hand side corner, total probability is always 1, okay, total probability, and that is nothing but probability of an event happening plus probability of the event not happening, okay, P bar, it is expressed as P bar, or you can simply write as not happening. No probability is nothing but 1, right? Probability plus no probability is 1. You will see how to use this in the sums which are going to come ahead, right? But just remember, probability is what I want divided by total. Whenever there is and, we multiply. Whenever there is or, we add, right? And total probability is always 1. It cannot be greater than 1. And probability of event happening plus the probability that the event does not happen is always equal to 1, right? See how easy it is. Let us see how easily we can solve the sums related to probability using these 2 to 3 small concepts. But before that, what we will see is the common type of sums which are asked in probability. Generally, there are few type of sums which are very common in probability, that is, those scenarios are generally used. The first one is related to a coin. Yes, coin. A coin has two faces, okay, heads and tails. In childhood we must have, or while playing cricket or something like that, while doing a toss, we generally have heads and tails, right? A coin has always two faces, heads and tails, right? That means there are only two possibilities, right? Two possibilities in total. Either you will get a head or you will get a tail. Now don't consider the possibility that the coin stands upright on the ground, okay, such scenarios are not taken into consideration. So there are only two possibilities, that there is heads or there is tails, right? Now the second type of sum is of cards, the playing cards which you must have played during summer vacation and all that stuff. So there are 52 cards in a well shuffled deck, okay. So that means there are 52 possibilities, right? There are 52 different cards. So there are 52 different possibilities. These 52 cards have 13 cards of spade, 13 of heart, okay, 13 of club and 13 of diamond, right? Out of that, spade is black, heart is red, club is black and diamond is again red. So 26 red cards, 26 black cards. Again, these are nothing, these 52 cards. Out of that, for each of them we have a card numbered from 2 to 10. There is a jack, there is a king, there is a queen and there is a ace, right? So there are 26 red cards and 26 black cards. So problems or numericals can be asked based on cards. The third common type is nothing of a dice, okay, dice which we roll while playing board games. So a dice is how it is a cube. Dice is nothing but a cube and it has how many? 6 faces, right? And there are some numbers over here, right? 1, 2, 3 like that. So there are 6 faces and each of them has a unique number from 1 to 6, that is 1, 2, 3, 4, 5 and 6. So if there are 6 faces, each having one number, there are 6 possibilities, right? A symmetrical dice or a fair dice means one which has not been tampered upon, okay, that is generally taken for calculation. It has 6 faces, that means it has 6 possibilities. Now the fourth type is generally the most asked type, that is nothing but regarding socks, regarding colorful balls, okay, or colorful marbles, right, etc. Or shirts are there, right? Everything, and miscellaneous like number of students, how many are selected, what is the probability of it being a girl or a boy, etc. Now the possibilities over here depend upon the number of balls, total number of socks, total number of marble, shirts, etc. So this is nothing but case by case. We will see how to solve these kind of sums also. So these are 4 to 5 type of sums which are commonly asked in probability. They might ask something different from this also, but that is very, very rare. Most of the probability sums are featured on these types only. So get acquainted with these types and you will be able to solve almost all sums related to probability. Let's move to question number 1. Suresh keeps all his socks in a single drawer. He has 24 pairs of white socks and 18 pairs of grey socks. Suresh picks 3 socks randomly. Find the possibility of Suresh choosing a matching pair. Okay, very easy. You can go by formula also, but let us see if we can solve this by normal logic. Let us see. What have they given? Suresh has one drawer. Okay, this is one drawer of Suresh, and in that he has 24 pairs of white socks, 18 pairs of grey socks. Now pairs, that means one pair has 2 socks. So he has 24 into 2, 48 white socks. He has 18 into 2, 36 grey socks. Okay, Suresh picks 3 socks randomly, right? So he picks 3 socks randomly. Let us say first he picks out of these 2 colors. Say he picks white sock first. Okay, 3 socks are picked by him. First sock which he picks, let it be white. Now he goes, again he closes his eyes and picks up the second sock. Let it be grey. Okay, now again he closes his eyes and again he picks another socks. Now the third socks can be white or grey. Okay, say if it is white, we got a matching pair, right? Say if it is grey, okay, still we'll get a matching pair. What does that mean? Whatever choice of socks, whatever 3 socks he picks, we will always get a matching pair. That means that this event will always happen. So every time the probability will be nothing but 1. There is no chance, or there is nothing like 4 by 6 or 1 by 2 or something like that. Suresh will always get a matching pair. Whenever an event always occurs, the probability is 1. Like say, if we say that sun rises for 365 days every day. So what is the probability that the sun will rise on a Sunday in the same year? Now what will happen over here? Every day the sun rises. Okay, so it will rise on Sunday also. That means the sun will always rise. So always on Sunday the sun will rise. So the probability will be 1, because that event is always going to happen. Take a look over here. First, if say there are again 3 socks. Okay, say Suresh closes his eyes and picks a say grey socks. Okay, again he closes his eyes and picks another socks. If it is again grey, here he got a matching pair. So this is going to happen. Say same case, say he picks white, again it will be say second also he picks white, again he got a matching pair. There is no need to consider the third sock, right? So be it any case, Suresh will always get a matching pair if he is picking up 3 socks randomly in this situation. So the probability of or possibility of Suresh choosing a matching pair is 1. See how easy it was. Moving to the next question. What will be the possibility of drawing a jack or a spade from a well shuffled standard deck of 52 playing cards? Now this is of the common type cards, right? What have we learned? There are 52 cards, right? That means the total possibilities are 52, right? Now out of that, what have we also learned? Probability is nothing but what I want divided by total. We already know the total as 52. Okay, let us see how to solve this sum. What are they saying? What is the possibility of drawing a jack or a spade from the deck? Okay, that means you pick up one card, that should be a jack, or you pick up one card, that should be a spade, right? Or means what? We add, so put in a plus sign. Now we pick out one card, that should be a jack. There are 4 suits, okay, in a well shuffled standard deck of 52 playing cards. There are 4 suits, one of club, one of spade, one of heart, one of diamonds, right? There are 4 suits, 13 cards of club, spade, and each of them has one jack, right? Each of them has one jack. So how many jacks are there? There are 4 jacks. We want to pick one jack, right? We have to pick one jack. So there are 4 possibilities. So what I want? Jacks. 4 jacks are there. I can pick any one of that. How many total are there? 52 cards are there in total, right? This is the probability for picking out a jack. Now probability of picking out one card, which is a spade. How many spade cards are there? There are 13 club cards, 13 spade cards, 13 heart cards, and 13 diamond cards, right? So there are 13 spade cards. I need one spade card. So there are 13 choices which I have. So what I want? 13 spade cards divided by how much is the total? The total cards are 52. Now if you observe closely, while choosing the jack, I can choose a jack of spade, correct? And what will happen? That means that I have chosen a jack, okay, plus I have chosen a jack of spade also, okay. I have chosen a jack, right, which is of spade. So this probability also gets satisfied and this gets satisfied. That means there is a double counting over here, okay. First we included, say if we choose a jack of spade, right. So jack of spade which is there, if we choose over there, probability of choosing a jack of spade has been included over here. And again a spade cards, 13 spade cards which are there, that includes a jack of spade. So probability of choosing a jack of spade has also been included over here. So there is double counting, right? This double counting will give us the wrong answer. So what we need to do is we have to subtract the possibility of one jack of spade being chosen. So let us choose now jack of spade. How many jack of spades are there? There is only one jack of spade. And how many total cards are there? 52. We have to subtract this double counting, right? Okay, what do we get then? 4 plus 13 is 17. 17 minus 1 is 16 upon 52. 4 4s are 4, 13s are. This is the probability of choosing a jack or a spade from a well shuffled deck of 52 playing cards. Now again I will explain why we subtracted 1 by 52. Okay, first probability of choosing a jack is nothing but 4 by 52 because there are 4 jack cards in a deck. Okay, so I can choose any one of them. So there are 4 choices which I got. So the probability is 4 by 2. What I want divided by total, plus what I want is a spade card. So there are 13 spade cards. If we choose 13 spade cards, anyone I can choose. I want one spade card. I can choose any one of the 13 spade cards. So the probability of getting a spade card is 13 by 52, right? And since it is OR, we add them. Okay, for jack card we have 4 by 52. Okay, plus the spade card 13 by 52. But in the jack card I can choose a jack of spade, correct? So that probability I have included over here. This is right. But again the same probability of choosing a jack of spade is included over here. Why? Because there are 13 spade cards and one of the spade card is jack. So again jack of spade is counted over here. That should not happen. There should not be double counting. So we have to remove the jack of spade probability from this addition or this sum. So what is the probability of choosing a jack of spade? There is only one jack of spade. So we will write 1 divided by 52. That is the total. What I want divided by total. So we will get 4 by 13. We will see more such sums. So you will become more comfortable with this double counting concept. Okay. Moving to next question. A box has 6 black, 4 red, 2 white and 3 blue shirts. When 2 shirts are picked randomly, what is the probability that either both are white or both are blue? Again, very easy sum. Let us see how to solve it. What have we learned earlier? That probability is nothing but what I want divided by total. Okay. Now there is a box. Okay. In that box there are 6 black shirts. Okay. There are 4 red. There are 2 white and there are 3 blue shirts. Okay, how many? 3 blue shirts. Total number of shirts are 6 plus 4 is 10 plus 5. 15 shirts are there in total. So 15 shirts are total. That means 15 is the total number of possibilities. So we know what are the total possibilities. That is 15. Okay. Now let us see how to solve this sum. What have they given? They pick out 2 shirts. Okay. They first pick out 2 shirts. That means they pick the first shirt and then they pick the second shirt. So and means multiplication, right? So first they pick the first shirt and then they pick the second shirt. Now over here, please remember that they pick the first shirt, they do not put the shirt back in. Okay, they pick the first shirt, keep it in hand, then they pick the second shirt again, right? Now what they given? They want either both are white. So the 2 shirts which are picked should be white, or find the probability that the 2 shirts that are picked are blue, right? So we have to find the probability that both are white or both are blue. Or means what? Addition. So what we need to do is, first we need to write plus over here. Okay. Now let us start with choosing the white shirts. We choose two white shirts. We have seen how to choose the two shirts. We choose one white shirt and then we choose the second white shirt. Same way, we choose the first blue shirt and then we choose the second blue shirt. That is, again one blue shirt is chosen, right? And we do not replace the shirt. We choose one white, keep it in hand, and then we choose the second white. So what is the probability first of choosing one white shirt? How many white shirts are there in total? There are two white shirts. How many total possibilities are there? 15. Okay, there are two possibilities of white shirt. I can choose any of the shirts. So 2 should be over here. What I want is white. Okay, what I want is white. So 2 white shirts are there. So 2 would come in numerator divided by total possibilities, that is 15. And I keep that white shirt in my hand. Okay, now I go and choose the second white shirt. Out of 2 white shirts, I have already chosen one white shirt. So how many white shirts remain in the box? 2 minus 1, 1. So one white shirt remains. Okay, so I want to choose white. What I want is white divided by total possibilities. I've already taken out one shirt. I've kept it in my hand. So how many total shirts are remaining in the box? 15 minus 1, 14. Okay, 14 shirts remain. This plus sign comes over here. Okay, now I choose a blue shirt. How many blue shirts are there? 3. I want blue. So 3 possibilities of blue are there. Divided by total number of possibilities, 15. I choose one blue shirt and keep it in hand, and then I go and choose the second. So and means multiplication. Now I choose the second shirt. Already I chose the first shirt. Okay, first blue shirt. So how many blue shirts are remaining? 3 minus 1, 2 blue shirts are remaining. So if I want blue, only 2 possibilities are remaining. Divided by total possibilities. Out of 15, I have already chosen one shirt over here. Okay, so how many shirts are total remaining? 15 minus 1, 14, right? So what is the total possibility? 2 sevens are, okay, 2 into 7s are, right? What do we get over here? 1 upon 15 sevens are 105 plus 3 upon 105, that would be equal to 4 upon 105. This is the probability that either both are white or both are blue. See how easy it was. Just remember, probability is what I want divided by total, right? And here we are not replacing the shirt. We just take one shirt, keep it in hand, and then we pick out the second shirt. That is the reason we reduce the denominator by 1. Okay, moving to next question. Question number 4. A pot has 2 white, 6 black, 4 grey and 8 green balls. If one ball is picked randomly from the pot, what is the probability of it being black or green? Again, extremely easy. Probability is what I want divided by total. There is a pot. There are 2 white balls in it, 6 black balls in it, 4 grey balls in it and 8 green balls in it. Okay. What are the total number of balls? 6 plus 2 is 8 plus 4, 12. 20 balls are there in total. That means there are total 20 possibilities, right? What do? We have to pick one ball randomly. What is the probability that it is black or green? Okay, that means we choose one ball. What is the probability of it being black? How many black balls are there? 6 divided by total possibilities 20. Or means plus sign. Green. What is the probability that I choose a green ball? There are how many possibilities of green? I want green, but there are 8 possibilities of green. So 8 divided by total possibility 20. What you will get over here? 14 by 20, that would be 7 by 10. So this is the probability that the one ball which we picked randomly was black or green. Moving to question number 5. There are 2 pots. One pot has 5 red and 3 green marbles. Other has 4 red and 2 green marbles. What is the probability of drawing a red marble? Now pay very close attention over here. This is a very easy sum, but this is the kind of sum where if you do not pay attention to what is asked, you will get wrong answer 100% of times. Okay, every time you will get a wrong answer if you do not pay attention to what exactly is asked. Okay, what have they given? There are 2 pots. Okay, 2 pots. This is the first one, this is the second one. Okay, this pot has 5 red and 3 green marbles. Okay, second pot has 4 red and 2 green marbles, right? What they say, what is probability of drawing a red marble? What you will do directly, you might add these marbles and write the probability, which is wrong. Okay, first we do not know from which pot has been the red marble been picked. So what we can have, we can either have the red marble from the first pot, or we can have the red marble from the second pot, right? So or means addition. Okay, or means addition. That means the first we have to find the probability of choosing a red marble from the first pot. Then we have to find the probability of choosing the red marble from the second pot. Okay, and then we have to add that. But before going to that, what we have to see is the probability for choosing the pot. Okay, there are two pots. Okay, so which pot do we choose? What is the probability of choosing the first pot? Okay, we might choose pot 1 or we might choose the pot 2. So probability of choosing pot 1 or pot 2, that also has to be considered. Let us see how to think about this problem. First we'll see is that we are choosing the red marble from the first pot. Okay, now first, before choosing the red marble, we have to first choose pot number 1. So what is the probability of choosing pot number 1? How many total pots are there? There are 2 pots. Okay, there are 2 pots, 1 and 2. Out of that, we want which pot? We want the first pot, that is 1. There is only one pot which is numbered first. So we want only the first pot, that is 1. Okay, this one. So what I want is 1 divided by total possibilities is 2. After choosing pot 1, okay, choose pot 1 and then choose the red marble. Okay, first choose pot 1 and then choose the red marble. Now let us choose the red marble from the first pot. How many I want red marble. Okay, how many red marbles are there? 5. So I have 5 choices. So what I want is red. Okay, divided by total marbles. 5 red plus 3 green is 5 plus 3 is 8. Right? This is the probability of choosing a red marble from the first pot. Or means addition, that we have written over here. Now second choice. Now choosing a red marble from the second pot. Okay. Now first we have to choose the second pot out of the 2 pots. How many pots are there total? 2. Out of that I want the second pot, this numbered pot. Okay. What is the probability of choosing this pot in specificity, or specifically this pot? There is only one pot, number 2. Okay, there is only pot which has number 2, only one pot is there. So the probability is 1. Okay, 1 by 2, probability is 1 by 2 because I want the second pot, that is nothing but 1, divided by total possibilities is 2. After choose the second pot and then choose the red marble from the second pot. Okay, choosing the red marble from the second pot, how many red marbles are there? 4. Okay, divided by total marbles, 4 plus 2 is 6. Now solve it. What do you get over here? You will get 5 upon 16 plus, okay, plus 4 upon 12. What is the LCM? LCM is 48. 5 3s are 15 plus 4 4s are 16. That would be 31 upon 48 is the probability of drawing a red marble. See, the twist over here or the trick over here was to consider the probability for choosing a pot. If there are 2 pots, choosing one pot out of 2, the probability will always be 1 by 2 for both of them. Probability for choosing pot number 1 is 1 by 2. Probability for choosing pot number 2 is also 1 by 2. But we have to consider that 1 by 2 while choosing the red marble. Moving to next question. Question number 6. In a set of 30 game cards, 17 are white and rest are green. 4 white and 5 green are marked important. If a card is chosen randomly from this set, what is the possibility of choosing a green card or an important card? Okay, now this is based on cards, but these are not our normal cards. These are game cards which have total 30. Okay, there are 30 game cards in the set. So total possibilities are 30. Now what we have to do? We have to choose one card. How much? One card, and it can either be a green card or a important marked card. Okay, right? What or means what? Plus sign. Now what is the probability of choosing a green card? How many green cards are there in total? There are 17 white, total cards are 30. Okay, there are 17 white, total cards are 30 total, right? So how many green cards are there? 30 minus 17 equal to 13 green cards are there. So I want to choose one green. I want to choose green. What I want is green. So 13 probability, you know what it is. What I want divided by total. What is total cards? 30, right? I want green. I want one green card. I want green. So total possibilities are 13. 13 by 30 plus I want an important card. How many cards are marked important? 4 white and 5 green cards are marked important. That means total 4 plus 5 is 9. 9 cards are marked important. I want an important card. So 9 possibilities are there. 9 choices are there with me. Divided by total cards are 30. Now over here if you see, out of the 9 important cards, 5 are green cards. Okay. Now this is similar to double counting which we have seen at the start in the first numerical. Now when I choose an important card, it can be a green card. Okay. That means that over here I have already included those 5 green important cards. Again over here I am including those 5 green important cards. Okay, 5 green cards which are important, right? Because total green cards are 13. That will include the 5 green important cards. So this 13 includes this 5 green important cards. And again over here I am considering the 5 green important cards. Okay, in this 9. So we have to subtract this double counting. What is being counted double? The 5 green important cards are being counted double. What is the probability of choosing the 5 green important cards? How many cards, green cards are there? How many green important cards are there? 5 divided by total cards are 30. What is the probability that you get? 13 plus 13 minus 5 is 8. 8 plus 9 is 17 by 30. This is the probability of choosing a green card or an important card. Just remember this concept of double counting. Make sure that you are not counting one card twice. Okay. Moving to next question. Question number 7. A box has 6 black, 4 red, 2 white and 3 blue shirts. Find the probability of drawing 2 black shirts if they are picked randomly. Okay. So what they are saying, there is a box. The box has 6 black, 4 red, 2 white and 3 blue shirts. So in total there are 6 plus 4, 10, 15 shirts. This is the total. We have to draw 2 shirts. Draw first shirt and then draw the second shirt. Do not replace it. Okay. First has to be black, second also has to be black because they are asking probability of drawing 2 black shirts. What is the probability of drawing the first black shirt? There are 6 black shirts in total. Divided by total number of shirts are 15 and means multiplication. I do not replace the shirt. I keep the shirt in hand. So now if I want to draw a black shirt again, so how many black shirts are remaining? 6 minus 1 is 5 divided by total shirts. Out of 15 already 1 shirt is in my hand. So how many shirts remain? Total possibilities are now 14. 6 5s are 30 divided by 15 into 14 is 210. 1s are 7s are. 1 by 7 is the probability of choosing 2 black shirts. Moving to question number 8. Question number 8. A box has 6 black, 4 red, 2 white and 3 blue shirts. What is the probability that 2 red shirts and 1 blue shirt get chosen during a random selection of 3 shirts from the box? Again, pretty easy. Let us write over here. There are 6 black, okay, 6 black shirts, 4 red shirts, okay, 2 white shirts and 3 blue shirts. Total number of shirts are 15. There are total 15 shirts. So total possibilities are 15. What they are saying? We need to choose 3 shirts. That means choose the first shirt and then choose the second shirt and then choose the third shirt. Do not replace it. Keep first shirt in hand, then choose second. Keep first and second in hand, then choose third. Now what they want is 2 red and 1 blue shirt. Okay. Total 3 shirts. Out of that 2 should be red and 1 should be blue. Okay. What I can do is I can choose a blue shirt first. Okay. First shirt I choose blue and then I choose the red shirt and then I choose the second red shirt. Or what I can do, first I can choose a red shirt and then I can choose a blue shirt and then I can choose the third shirt, that is nothing but again red. Or what I can do, choose a red shirt and then red shirt as second and the blue shirt as third. These are all the possible combinations that can be done, right? I can choose blue, red, red, or I can have red, blue and red, or I can have red, red and blue. Now we have to find the probabilities individually for all these combinations. Okay, now in the first scenario, okay, where I choose blue, red and red, this is the second scenario, this is the third scenario. In the first scenario, first I choose a blue shirt. What is the probability of choosing a blue shirt? I want blue. How many blue shirts are there? 3. Total shirts 15 multiplied by, I take a blue shirt and keep it in my hand. Okay, now I choose a red shirt. How many red shirts are there? 4 divided by total number of shirts. I already have chosen one shirt and it is in my hand, so total number of shirts remaining are 14. 15 minus 1, 14 multiplied by, again I want to choose a red shirt. Now I have already chosen a red shirt earlier over here, so how many red shirts are remaining? 4 minus 1 is 3 divided by, now out of 14, again out of 15 I have chosen one shirt, second shirt, two shirts in my hand, so now 13 remain. Okay, in the box total 13 shirts remain. Or what can I do? I can have red shirt first, 4 possibilities divided by 15. I can have blue shirts second, 3 blue and 14 shirts remaining because I have already chosen one shirt over here, multiplied by 13 shirts remaining because 2 have already been chosen. Now again I want red shirt, already one red has been chosen, 4 minus 1, 3 remain. Or I can choose a red shirt, 4 by 15 multiplied by, again I choose a red shirt, already one shirt, red shirt is gone, so only 3 remain divided by 15, one shirt is already in my hand, so now it would be 14 multiplied by blue shirt, 3 blue shirts are there, okay, divided by, out of 14 again one shirt has already been chosen over here, so only 13 remain. What you will have over here? Or is nothing but addition, or is nothing but addition. If you see everywhere it is 3 4 4 3, that is 4 3 3 4 3 3, 4 3s are 12, 12 3s are 36 divided by 15 into 14 into 13, okay, plus you will get the same over here, 15 into 14 into 13 plus 36 divided by 15 into 14 into 13. On solving this, okay, what is this? You can simply write 3 into 36 upon 15 into 14 into 13, right? So 3 5s are, okay, 3 into 12s are, 2 6s are, 2 7s are, okay. You'll on solving this is nothing but 3 into 6 upon 5 into 7 into 13. On solving this you will get the answer as 18 upon 455. So this is the probability of choosing 2 red shirts and 1 blue shirt. If you see carefully, all the 3 times, in all the 3 cases you have the same probability. So whenever you have such a scenario where you have to choose 2 red and 1 blue, and you can choose it in 3 different ways, just remember, find probability for 1 and just multiply it by 3. You will get, because anyways you will be getting the same probability here also, here also. So just find this, multiply by 3. Okay, moving to next question. Question number 9. A box has 6 black, 4 red, 2 white and 3 blue shirts. What is the probability of picking at least 1 red shirt in 4 shirts that are randomly picked? Again, very easy. There is a box, there are 6 black, 4 red, 2 white and 3 blue shirts. Okay, total shirts are 15. There are 15 shirts. This is nothing but the total. Okay, so here we want to pick 4 shirts. So we pick the first, and those 4 shirts has to be, in those 4 shirts we need to have at least 1 red shirt. That means these 4 shirts can have 1 red shirt or 2 red shirts or 3 red shirts, or all the 4 can be red shirts. Okay, so we can find the individual priorities for the probabilities for these and we can get the answer. But let us take a different way to solve this sum. Let us learn a new way. Okay, we have already learned this trick at the start, but let us apply it, see how to use it. Now whenever you see the word at least, okay, please remember, you can try to use this trick whenever there is a word at least over here. What do you mean by at least 1 red shirt? That means that you can have at least 1 or 2 or 3 or 4 red shirts. Okay, now what have we learned? Probability is what I want upon total. This is again and probability of an event happening plus the probability of the event not happening is nothing but 1. Why? Because total probability is 1. So probability of an event happening plus probability of the event not happening is 1. That means choosing at least one red shirt, probability of choosing at least one red shirt plus probability of choosing no red shirt at all should be equal to 1. Now why did I say no red shirt at all? Probability of choosing no red shirt at all, because at least one includes one shirt or 2 red shirts or 3 red shirts or 4 red shirts. So all these possibilities are gone, right? So regarding red shirts, all the possibilities are gone. So you can have only 0 red shirts where at least one red is not there. If we choose 2 red shirts, at least one red comes, 3, at least one red comes, 4, at least one red comes. When you choose no red shirt at all, then only we can say there is at least no red, okay, in this. So probability of choosing at least one red shirt plus probability of choosing no red shirt at all is 1. So probability of choosing at least one red shirt is 1 minus probability of choosing no red shirt at all. Okay, so let us now go on to find the probability of not choosing a red shirt. Okay, what is the probability, right? How many total shirts are there? 15. Out of the 4 are red. So how many non-red shirts are there? It is 6 black plus 2 white plus 3 blue. 6 plus 4 or 6 plus 2 plus 3 blue, that would be 8 plus 3. 11 shirts are there which are non-red. Okay, these are non-red shirts. If you choose any one of these shirts, okay, it would not be red, right? So what is the probability of not choosing a red shirt, not choosing 4 red shirts? First I choose one shirt and then I choose the second shirt, then I choose the third shirt, then I choose the fourth shirt. Okay, what is the probability? It would be choose the first non-red shirt. How many non-red shirts are there? I have 11 choices divided by total number of shirts 15. Then now I have chosen first non-red shirt and kept it in my hand. Okay, it can be black, white, blue, it doesn't matter. Now I choose the second non-red shirt. Already 1 is in my hand, so 11 minus 1 is 10 divided by out of 15. Already one shirt is in my hand, so 15 minus 1 is 14. Okay, this is the second non-red shirt. Now I choose the third non-red shirt. Already 2 in my hand. 11 minus 2 is nothing but 9. So 10 minus 1 is 9 divided by 13 because 3 are in my hand. Okay, then 8 divided by 14. This choosing the fourth non-red shirt. Okay, now what do I get over here? 4 2s are this comes out to be 12. Okay, 4 2s are 4 3s are 3 3s are okay, 3 3s are 3, 5s are okay, 5 2s are 2, 7s are what do we get? 22 upon 91. This is the probability of not choosing even one red shirt, right? Then what is the probability of choosing at least one red shirt? P is 1 minus 22 upon 91, that would be 69 upon 91. This is the probability of choosing at least one red shirt. How did we did it? We saw the word at least, so we tried to use the formula probability of choosing red shirt plus probability of choosing at least one red shirt plus probability of not choosing at least one red shirt is equal to 1. Not choosing at least one red shirt means not choosing any red shirt. Okay, because at least will include 1, 2, 3 and 4 red shirts. Okay, so not choosing at least or even one red shirt means not choosing any red shirt. That would be equal to 1. We found the probability of not choosing any red shirt, subtracted it from 1 and we got the answer. Moving to next question. On rolling a dice 2 times, the sum of 2 numbers that appear on the uppermost face is 8. What is the probability that the first throw of dice yields 4? Now again very easy, this is the dice kind of sums, okay, which we have seen earlier at the start that dice has 6 faces. So there are 6 possibilities in total, right? So dice has 6 possibilities, and what are the numbers on the face of dice? 1, 2, 3, 4, 5 and 6. These are the 6 possibilities. What they say, a dice is rolled 2 times. That means dice is rolled first and then the dice is again rolled second time. So in the first time there are 6 possibilities and again in the second time there are 6 possibilities. So total there are 6 into 6, 36 possibilities in total. Okay, so whenever the dice is rolled 2 times, total possibilities are 36. Now what they are saying is that 2 numbers will appear when we throw the dice 2 times. 2 numbers will appear on the uppermost face. Addition or the sum of the 2 numbers is 8. So out of all these numbers, all these 6 numbers, which combination has the addition 8? We will have 2 and 6, we will have 3 and 5, we will have 4 and 4, okay, then we will have 5 and 3, then we will have 6 and 2. Now 2 and 6 and 6 and 2, they are not the same. Over here, when you throw the dice first, you will have 2 on the first time, then you will have 6 in the second time. Here you will have 6 in the first time and 2 in the second time. So it is not the same. These are different scenarios. Out of that, we want the probability that the first throw of dice yields 4. That means when you throw or roll the dice first, you should get a 4. Over here you get a 2. So this is not the case. Here it is 3. Here it is 4. So this is the case. Here it is 5. So not the case. Here it is 6. Not the case. So there is only one scenario where the throw of the dice on the first time yields 4. Okay. And the addition is also 8. So probability is what I want divided by total. Total is 36 possibilities. What I want, first throw must be 4 and addition should be 8. There is only one scenario like that. So 1 by 36 is the answer. Okay. Moving to question number 11. A box has 5 black and 3 green shirts. One shirt is picked randomly and put in another box. The second box has 3 black and 5 green shirts. Now a shirt is picked from second box. What is the probability of it being a black shirt? Now pay attention, this is very easy sum actually, but you might make silly mistakes and get the wrong answer. Let us see what have they given. There are 2 boxes, okay. In the first box there are 5 black and 3 green shirts, okay. Then one shirt is picked at random, it is put in the second box. The second box has initially 3 black and 5 green shirts, okay. Total number of shirts over here are 8, total number of shirts over here are 8. Now what they ask is that a shirt is picked out from second box, okay. This is the first box, this is the second box, okay. One shirt is picked out from second box. What is the probability that it is a black shirt? Now you might directly write the probability is 3 upon total number of shirts 8, but it is wrong, okay. Or you might add the shirts and write the probability that 5 plus 3 is 8, total number of shirts is 16, so 1 by 2. Again it is wrong, the approach is wrong. Now what you have to consider over here is, first one shirt is taken out from here and put into the second box. So that shirt can be black, okay, that shirt can be black, or that shirt can be green, okay. So from the first box you take out one shirt and put into the second box. It can be a black shirt or it can be a green shirt, okay. So if you pick out one black shirt, okay, and then you put over here, okay, or you can pick out one green shirt and then you put over here. And after that what you do? And after that you pick out one black shirt from the second box. Over here also, and after that what you do? You pick out one black shirt from the second box, okay. That is what you do. Now let us assume for the first case that you are choosing a black shirt from the first box and putting it into the second box. What is the probability of choosing a black shirt? There are 5 black shirts, I want black. So there are 5 black shirts divided by total number of shirts. 5 black plus 3 green is 8 shirts. That means probability of choosing a black shirt and putting it into the other box is 5 by 8. So this probability you got as 5 by 8. Now what you do? And after this you choose one black shirt from the second box, okay. Now the second box initially had 3 black and 5 green shirts. This one black shirt gets added. How many black do you get? You get 4 black shirts and 5 green shirts. Now you choose one black from this. What is the probability of choosing one black shirt from the second box? How many black shirts are there now? 4 divided by total number of shirts, 4 black plus 5 green, 9 shirts. So first you put one black shirt into second box, then you choose the one black shirt from second box. So the probability would be for this is 4 by 9, okay. Choosing one black shirt from second box, total probability is how much? 5 by 8 multiplied by 4 by 9 would be 20 by 72 for the first scenario where you are choosing the black shirt. Okay, right from the start, from the first box you are choosing black shirt. Now instead of black you can choose a green shirt from the first box. What will be its probability? The probability will be simply choosing a green shirt. That means there are 3 possibilities because there are 3 green shirts divided by total number of shirts. Now this green shirt goes to the second box. Okay, now you have to choose the black shirt from the second box. How many black shirts are there? 3 black shirts, and now 1 green has been added, so total number of shirts will be 3 black plus 5 green, that is 8 shirts plus 1 green from the previous, so that would be 9. Correct? So what would be the total probability in the second case? 3 by 8 multiplied by 3 by 9. What it would give you? 9 upon 72. This is the probability in second case. We know we can choose first case, that is black shirt, or we can choose second case, that is green shirt. So first scenario or second scenario, that means first scenario or second scenario, that is addition, or is nothing but addition. So we get 29 upon 72 as the probability of the one shirt which we pick from second box to be black shirt. Moving to question number 12. Question number 12. What is the possibility of having 53 Thursdays in a non-leap year? In a non-leap year, there are 365 days. That includes 52 weeks and 1 spare day. Okay. Now, this one day which is there, it can be Sunday or Monday or Tuesday or Wednesday up to Saturday. So, there are 7 possibilities for this one day. In these 52 weeks, you will have 52 Thursdays, right? Okay. So this one day it has to be Thursday, then only it is possible to have 53 Thursdays in a non-leap year. Okay. So this one day has how many possibilities? There are total 7 possibilities. Probability is what I want divided by total. Total possibilities are 7. What I want 53 Thursdays. Already 52 Thursdays I have in a non-leap year, okay, because there are 52 weeks. I have 52 Thursdays. Now this one day has to be a Thursday. I want a Thursday. That means one day only I want Thursday, specifically Thursday. So I want 1. There is only 1 Thursday in every week. So probability is 1 by 7. Why 1 by 7? Because this one day can be any of those 7 days. So total possibilities are 7. It can be Sunday, Monday, Tuesday, anything. But I want specifically Thursday. So only 1 Thursday is there in every 7 days. So 1 by 7. What I want? Thursday. That is 1. Okay. And possibilities, total possibilities are 7. So 1 by 7. Moving to question number 13. In a drawer, there are 4 white socks, 3 blue socks and 5 grey socks. 2 socks are picked randomly. What is the possibility that both the socks are of same color? Very easy. Again, let us see what to do. We need to choose 2 socks. Both have to be of the same color. Okay. So 2 socks. So both can be white, or both can be blue, or both can be grey. Okay. How many are the total socks over here? 4 plus 3 is 7. 7 plus 5 is 12. Okay. There are 12 socks over here which are total. Now they can be, both can be white, that is choose first socks, choose the first white socks. What is the probability? 4 divided by 12. Why? Probability, look at the right hand side, probability is what I want divided by total. I want white, so there are 4 white socks, okay, over here, and so 4 possibilities divided by 12, and then I choose the second socks, okay, and since already 1 white socks has been taken, so probability will 3 by 11. Why 11? Because already 1 socks has been taken out and it is in my hand. Or means addition. Now, or I can choose 2 blue socks because it would be a same color only. So same color means 2 blue means same color. Condition gets satisfied. So choose 2 blue socks. Choose the first blue sock. Probability is 3 by 12. Why? Because there are 3 blue socks. So I need blue. 3 choices. Then choose the second blue sock and then I choose the second blue sock. So 3 minus 1 is 2 divided by 11 because already 1 blue sock is in my hand. So reduce by 1. Or means addition. Now I choose the grey socks. Okay. Choose the first grey sock. How many grey socks are there? 5. So choices are 5 grey socks. I want grey. So what I want is grey. 5 grey socks are there divided by 12 into 4 by 11. What do we get over here? 3 4s are 4 gets cancelled. So we will have 1 by 11 plus, okay, 3 4s are 2 2s are, what you will have 1 by 22, okay, plus what it is 3s are 5 by 33, what you will get LCM is 66, okay, 1 6 over here, 3 over here, and 5 33 into 2 is 65, 2s are 10, 19 by 66 is the probability. Moving to question number 14. What is the probability of drawing 2 clubs from a well shuffled pack of 52 cards? Again, the sum on cards. Total possibilities 52. Probability is what? What I want divided by total. What do I want? I want 2 cards. Both the cards should be club cards. That means take one club card and then again take the second club card, right? And means multiplication, okay, taking the first club card, okay, total possibilities 52. How many club cards are there in this pack of 52? There are always 13 club cards, right? So I want club, total possibilities for club are 13, okay. I take club card, keep it in my hand, I do not replace it, right? Now I want to pick up second club card. So already one club card has gone, second club card, while picking, total possibilities are 13 minus 1, 12, and already one card is in my hand. So 52 out of 52 cards, one card has gone. So how much remain? 51. So what is the probability? That would be simply be 13, okay, this is 13, okay, 13, 4s are 4, 3s are 3 into 17, 1 by 17 is the probability of choosing 2 clubs from a well shuffled pack of 52 cards. Moving to question number 15. What are the chances that no 2 boys are sitting together for a photograph if there are 5 girls and 2 boys? Now this sum is easy, it is not at all actually difficult. The only thing over here is that this is not just a probability sum, this is a permutation and combination sum plus probability sum, okay, permutation, combination sum and probability sum. But if you pay attention very closely, very carefully right now, you will be able to solve this sum even if you have not studied permutation and combination. You just need to remember very small trick, okay, very small trick. And what does that mean? What is that trick? Say if we have say 20 objects, okay, if we have 20 objects, okay, in a line, okay, if we have 20 objects in line, you can arrange these 20 objects in 20 factorial ways, okay. What is a factorial? 3 factorial is nothing but 3 into 3 minus 1 is 2 into 1. 8 factorial is nothing but 8 into 7 into 6 into 5. We have to go 1 down. 5 into 4 into up to 1, okay. 8 7 6 5 into 4 into 3 into 2 into 1. Same way 20 factorial will be what? 20 into 19 into 18 up to then 10 5 4 6 7 5 4 3 2 1, okay, till 1, okay. 20 factorial it will be till 1. So if you have n objects in one line, okay, they can be arranged in n factorial ways amongst each other, right? For example, if there are 3 people, 1 2 and 3, how we can arrange? We can have 2 1 3, we have 3 1 2, we have 3 2 1, like that. This is nothing but n factorial, okay. So if there are 3 people, you can arrange them in 3 factorial ways. If there are n people, you can arrange them in n factorial ways, okay. Just remember this, okay. This would be useful in permutation and combination also, but just remember this small trick over here and let us see how to solve using this trick, okay. Now what have they asked? They have asked the chances that no 2 boys are sitting together for photograph. Now what is probability? Probability is what I want upon total. Probability is what I want upon total, okay. How many total people are there over here? Total people are 5 girls plus 2 boys are 7 children, okay. There are 7 children. Now in how many ways can I arrange these 7 children? 7 factorial ways. This is the total number of ways, right? Okay. Now what have they given is that 2 boys are sitting together. No 2 boys should be sitting together. Total ways, okay, total ways would be 2 boys always sitting together, okay, plus 2 boys never sitting together, right? So if we find out the number of ways, this is the number of ways, okay, total ways total ways and total ways. Okay, total ways in which we can arrange the 7 children is 7 factorial. Okay, that is nothing but the number of ways in which 2 boys are always sitting together plus the number of ways in which the 2 boys are never sitting together, right? What do we want? We want the number of ways in which 2 boys are never sitting together. How to do that? Total ways we know 7 factorial. What do we need? We need this. We need to find out the number of ways in which 2 boys are always sitting together. How to find out? Let's see. Now, we have 2 boys who are always sitting together. We have to find out the number of ways. So, these 2 boys can be arranged in how many ways? 2 factorial, right? Now, we have 5 girls, okay? Now, let us consider these 2 boys as single group. So, wherever this group moves, these 2 boys will always be together. So, we have 5 girls and 1 group. How many people we have total? 6. You can arrange these 6 people in 6 factorial ways. So, whenever they arrange the group, that means this group can come over here or in between the 5 girls anywhere and all that stuff. These 2 boys will always be together. That is the reason we considered it as a one group, right? So, we have 5 girls and 1 group, that is total 6 people which can be arranged in 6 factorial ways. And this group, okay, this group of 2 boys can be arranged in 2 factorial ways amongst themselves. First boy, second boy, it can be second boy, first boy also, okay. So, 2 factorial ways. So, total number of ways in which 2 boys are always together is 6 factorial and 2 factorial, 6 factorial into 2 factorial, right. So, what do we have over here? Let us substitute the values. We have 7 factorial would be equal to 6 factorial into 2 factorial would be equal plus total number of ways in which the 2 boys are never together, okay. Total ways in which 2 boys are never together. So, what are the total ways in which the 2 boys are never together? It is 7 factorial minus 6 factorial into 2 factorial. What is 7 factorial? We know 7 factorial is 7 into 6 into 5 into 4. But if we observe, take a look over here. What have we written? 8 factorial is 8 into 7 into 6 into 5 into 4. That is nothing but 8 multiplied by 7 factorial. Correct? 7 factorial is 7, 6, 5, 4, 3, 2, 1. Same way over here, 7 into 6 factorial minus 6 factorial into 2 factorial is nothing but 2 into 1, that is 2. So, we will have the answer as 6 factorial common, 7 minus 2 is 5. This is the number of ways in which the total 2 boys will not be together, okay. Now, this is not the answer. What is the answer? What do we want actually? Take a look over here. We want the probability, or come directly over here. We want the probability where the 2 boys are not sitting together. Probability is what I want divided by total number of ways, or total number of ways of arranging the 7 children is 7 factorial. What I want is 2 boys not sitting together for the photograph, okay. How many ways? In how many ways both the boys are not sitting together? We have calculated 6 factorial into 5, correct. 7 factorial can be written as 7 into 6 factorial. This gets cancelled. Answer is over here 5 by 7. So, the probability or chances that no 2 boys are sitting together is 5 by 7. Did you understand? It is very easy. It includes concepts from permutation, combination, only one small concept of n factorial. We wanted the chances that no 2 boys are sitting together. So, we find out total ways in which all people are sitting together, and on the top it is what we want, that is number of ways in which 2 boys are not sitting together. Directly we cannot find out. So, we went roundabout manner, that is total ways is nothing but 2 boys always sitting together plus 2 boys never sitting together. And always sitting together means, let us consider the 2 boys as one group. So, we will have 6 people total, 5 girls and 1 group, that can be arranged in 6 factorial ways, plus the 2 boys can be arranged in 2 factorial ways amongst themselves. So, total number of ways in which 2 boys always sit together is 6 factorial into 2 factorial. Subtract it, get the answer as 6 factorial into 5, divide by 7 factorial, get the answer as 5 by 7. Moving to next question. Question number 16. When 2 coins are tossed simultaneously, what are the chances of getting at least one tail? Okay, now this is the sum on coins, okay. What is the total possibilities for coins? Heads and tails, that is 2 possibilities, right? When 2 coins are there, the possibilities, since 2 coins are tossed simultaneously possibilities would be more, right? Now there are three ways to solve this sum. What is one way? We want at least one tail. That means there can be, when two coins are tossed, there can be one tail, okay, or there can be two tails, right? Now this you can solve it this way, or what you can have is that at least getting at least one tail, probability of getting at least one tail is nothing but 1 minus probability of getting no tail, okay, right? This is the second way to solve it. What is the third way? It is the easiest way, and by common sense and logic, without using any formulas, we can solve it, okay? What it is given? Two coins are tossed, correct? So what will be the possible results for the two coins? Either the first will give head and the second will also give head, okay? Either the first will give head and the second will give tail, or first will give tail, second will give head, or first will give tail, second will also give tail. These are the only four possibilities that are possible. So total possibilities are how much? What is probability? What I want divided by total possibilities. Total possibilities are 4, correct? Now what I want is that at least one tail should be there. Is there one tail over here? No. Is there one tail over here? Yes. One tail? Yes. One tail? Yes. There are two tails. So at least one tail is there. So we have 1, 2 and 3. So there are three possibilities or three options where I get at least one tail. Probability is 3 by 4. See how easily we got the answer? Probability is extremely easy. You just need to remember probability is what I want divided by total, and probability of event happening plus probability of the same event not happening is equal to 1. That is probability of rain falling plus probability of rain not falling is nothing but 1. Total probability is 1. And if there are n objects, you can arrange them in n factorial ways, okay, n factorial ways amongst themselves. Just remember these things, just remember the common type of sums that are asked, and you will very easily be able to solve all sums related to probability. And most important thing, and means multiply or means addition, okay. This ends tutorial on probability. I hope this helped you understand probability a bit better. Do share the video with friends and give it a like if you liked it. Leave your comments and suggestions for us. You can even request a video on topic of your choice. Also, don't forget to subscribe to our channel and stay updated about upcoming tutorials.